During this offline activity, you're going to be asked to find the equations of lines in 4 different scenarios. The first scenario is when you are given a point and a slope. So what we want to do is take the formula that you learned when you were working on your Plato modules, the point-slope form, which would make sense because you have a point and you have a slope. So you get the point-slope form. Then you come up to your information and you identify the x, which is the 2, the y, which is -5, and the slope, or the m, which is 3/4. And you plug those into your equation in the appropriate spot. Once you've done that, label this as the point slope form. That's the first part of the problem. The second part is to take this and manipulate it so that it is in the slope-intercept form. And if you remember the slope-intercept form, it is y equals mx plus b. So we're after y alone on one side and the x and the y-intercept on the right side. Okay, so we have to do a little cleanup and a little moving. So right now, let's just get rid of this double negative right here and make it +5. And we have 3/4 x minus 2. Now I'm going to show you something that is not on the example in your paper. Your paper shows distributing the 3/4 and working with fractions. I know that some of you don't particularly like to work with fractions, so I'm going to show you a slightly different approach when your slope is a fraction. You can multiply both sides of the equation by that denominator. So we're going to multiply here by 4 and here by 4. When we do that, what happens is we momentarily get rid of the fraction by distributing the 4 here and canceling the 4 there. So for a little bit, we can work without fractions. If that's something you'd like to try, or if you need extra help on it, let us know. The example on your paper shows how to work with the 3/4, but this is perfectly legitimate to get rid of that fraction for a little bit. You'll see, it comes back. So what we're going to do is, now that we got rid of the fraction, we're going to distribute over there, which will give us 3x minus 6. Then we're going to move the constant over to the right side because all we want is y over on the left. So we have here 4y equals 3x minus, they're both negatives, so add them together, 26. Now just divide by the 4 that we used at the beginning. Divide everything by 4. You're going to see your equation come right back where you want it to be. Okay, so slope-intercept is equals 3/4 x minus 26 over 4, which is 13 over 2 if you reduce that fraction. This is slope-intercept. This slope-intercept form is y equals mx plus b. So our slope is 3/4 and our y-intercept is at 0, -13/2. This is considered slope-intercept form. The last form, which you haven't seen yet, is called standard form. Standard form is just what you get when you move the x over onto the left with the y, and it has no fractions and no negative x's. So what would happen if you had this problem is you have y equals 3/4 x minus 13/2. You would want to just take a step backwards, multiply everything by 4 so that you are not dealing in fractions, because we don't want fractions. And really, if you did it this way, you could just go back to that step. Now we have no fractions, because that's a big rule, no fractions. Then we are going to move the x. This is the main step right here. Move the x over onto the left. So we have negative 3x plus 4y equals negative 26. It's also usually desirable to not have a negative coefficient with x. So what we can do is just multiply both sides of the equation by negative 1. When we do that, it'll change your equation to being in perfect standard form with all of the signs changed. That is called standard form. So when you get done with each problem, you should have point slope form marked and labeled. Then you should solve for y, and that's your slope intercept form. Make sure you label it. Then you're going to move your x over onto the left. Make sure that you multiply through by a common denominator if there's a fraction. If there's a negative, multiply through by a negative, and you will then have standard form. So every problem that you do,